All right, you guys. So we're back. This is the third video around object-oriented programming. Today we're going to look at constructors, and then that naturally flows into overloading because we want to have the ability to create more than one. So what a constructor is it's actually the thing that generates an object in Java. So we've already been using, every time you use that new keyword, the thing that follows after it is the constructor. So it's actually creating an object in your code and allocating memory. The full line of code looks like this. You say, okay, so of the data type scanner from that class, I'm going to make a variable or reference named keyboard, and then I want to generate a new object, right? We could stop the line there. We could just say, I just want to reserve that variable name, that keyword. Later I'm going to do some stuff with it. But then this new says, okay, actually now create the new object of type scanner. And then here we're actually sending in information to that constructor, or the default constructor, we don't send anything. We just say make blank new object, and we can actually have the default constructor do whatever we want, okay? But that's what it does. So a constructor is kind of like a function call or a method call in that you have parentheses that call on it. Even the setup will be really similar, but what it actually does is different, and it's crucial. So following that new keyword, that's how we generate a new object. All right, so some key differences here. Really, there's two main differences with then kind of the goal. So the two main differences are the name of the constructor has to exactly match the class, whereas a method or a function can have any valid name. So going back up here, you notice that I made something of the car class, and so the constructor was named car. I made something of the scanner class, so the constructor was called scanner. Whereas afterwards, I could tell that, like, I could go Toyota dot do stuff method, right? I can make the method names whatever I want. The name of the constructor has to match the class. Also, there's no return type. So if I have a public class called car and I want to make a method, I have to. I don't even need to put the public or private access there, but I have to say, okay, it's returning nothing, and the name of it is convert, and I, would say it's taking in an integer. And so that would be how I'd make a basic method, okay? So the constructor, I do not put that void. I just go car, or better yet, before both of these, I go public. I want both the constructor and the method to be publicly available, but the constructor has to have the same name as the class, and there is no data type mentioned here. So I don't say it's returning a void. I don't say it's returning a string. It's because it has a job already. Its job is to allocate memory and create a new object. It doesn't answer a question, right? It's not saying, oh, convert this and give me an answer back, or like, what is your name? It's got a task, which is the creation, right? All right, and then lastly, we usually use the constructor to set up all the variables, whereas a method could be used for any purpose. The constructor has a preset job that it should be doing, right? So I just kind of mentioned the main differences. In terms of a function versus a constructor, the only differences are there's no return type, and the name is predetermined to be the name of the class. Otherwise, it's got the brackets, you got, all the code that runs inside, you still have the access, public, protected, private. All right, so let's jump into an example here. Here's an example right here that's for a chicken class. So I can make this bigger to look at it. So here there's only one variable in the class. The variable here is, whoa, I'm in that title, that's giant. The variable is a string called name. Now, the goal of a constructor is that it sets that variable up. So when you make the first object, I could have sent in a name and have it update or set that name. Okay, and we're going to talk about the default constructor in just a minute. But we could have also just used a method to do the same thing, right? So we could create a blank one and then later on set the name to update it. But that big difference here is the void data type versus no data type, and class name matches constructor, whereas the method has any name. All right, so by default, any blank class you create already has a default constructor, right? So if I go back over to my code and I've got the public class car here with nothing in it, I could instantiate this, right? In some runner over here, I could go public class car runner, and I'll just go my public static void main collection of string called arguments. Okay, so I could just go car, I don't know, Mazda equals new car. But where did that constructor come from, right? Like, I didn't make a constructor called car. So Java by default has a blank constructor in here. So if my class is publicly available, then this one is publicly available. And it's just no return type, so car, no inputs. And all it does by default is any variable that you don't mention. So if I have up here an integer a, if it's not set, then this default constructor sets all of it to 0, right? Or if I have a string, then it would set the string, I don't know, name. It would set name to essentially the 0 of a string, which is blank. So it zeroes out all of your variables if you don't assign them otherwise. However, you could overwrite that, right? Because it already exists, so I don't need to put it there if I'm not giving it any clear instructions, and I can go over to the runner and I can instantiate my new car, and I could even check, well, what's the value of A? And by default, it would set it to 0. It wouldn't say unassigned error. The constructor here would zero out all the variables. However, I could say, actually, whenever this default constructor is run, so by default, I'm saying there's just no inputs. That's the blank default one that already exists. I could actually say, you know what? I want A to always start as 100. And let's actually give this a real name. So let's call this num tires. And so I'm going to say by default, my car has 4 tires to start, right? Every single car coming off the factory line, right? And then by default, the name of the car is just going to be a new car. We can give it a space there. Right, so then whenever I do this, and I'm going to just go ahead and test this out. So I'm going to make a public thing that doesn't return anything. So a method that with no return value, that's just going to print values. Okay, and so that's going to just be system.out.println, and I'm just going to say there. So let's say tires and plus num tires. And I'll do the exact same thing with the other variables. So system.out.println, and we'll just go name is name. Okay, so I'm going to save that. This is 0422, and I'm going to name this the car class. And then this one over here, I'm going to save into that same directory as car runner. Okay, and now after I've made my Mazda, I'm going to say, Mazda, what are your values? Okay, I'm going to save it, so that just became blue. I'm going to open in CMD, and I'm going to Java C. I'm going to compile all of my .javas. I'm going to Java run the car runner, and we'll see that it, sure enough, it updated to 4 tires, and its name is new car. And that was because I made the default constructor here, car, and I'm going to scroll out just so we can see everything. I changed that default constructor to actually do something. So instead of being blank, whereas if I go in here and I just delete that whole constructor completely, or actually just to leave it in there, I'll do a multi-line comment. So slash asterisk to start it and asterisk slash to end it. So I'm going to save that, recompile, and then rerun it. And now we get, oh, it sets it to null, not empty string. Okay, so by default, it just zeroes everything out. So the car blank constructor just says, okay, so an integer goes to 0, and any, oh, it's because this is not a primitive, right? And so it just sets all the objects to null. So they're pointing at no memory, right? This object is blank. Okay, so let's go back over to constructors. So that's the default constructor that exists already, but you can, as I just did, make your own default constructor that actually does give correct starting values. But really the goal here is when you make a new thing, you want to be able to set its starting value. So I don't have to do something like back in my code, I wouldn't have to say, okay, so make a new Mazda, and afterwards go Mazda set tires to 4, and then like Mazda set the name to Mazda, and then Mazda set the year to, I don't know, I bought this in 2018, right? So I don't want to have to one by one set these values, or even say like I could have a function that does set values to 4 comma Mazda comma 2018. So that's a little more efficient, but still the goal here is to not have two separate lines. Instead of creating a blank object and then assigning it values, wouldn't it be great if we could just say create a new car with these values? And that way, after you've gotten information from, say, a user, or you're creating a video game or an application and you have the information, right away you could create an object with those starting values. So let's go back over to car. Let's have a num tire, a name, and a year. So let's up here make another integer called year. I'm actually just going to do this in the same line. So we've got 2 integers and a string name. I'm going to go back over here and say, okay, so by default, if I make a blank one, I'm just going to say the year is 2020. It's a brand new car, right? But I can actually have more than one constructor, right? Now, right now, this would cause an error, okay? Now, why would this cause an error? It's because there's ambiguity. So I would say, hey, I want to run, the car constructor, and say I left this all blank. What it would do is it would go over here and say, okay, what do you want? Oh, there's 2 of them. So there's 2 constructors with the exact same name. Like you can't do that. However, as long as Java knows how to distinguish between the 2, you can actually have 2 methods with the same name or 2 constructors with the same name. That's what overloading is. And so the way to distinguish between 2 constructors, because they have to have the same name, the name of the class, is by different inputs. So if there's no inputs, it'll run this constructor. However, if there's an int tires and a string, I'm going to call it name. Oh, let's call it name with a underscore. That's a good practice to get into to make a local copy. So I'm going to go underscore num tires. And then over here, we'll say next is int underscore year. So if they call on one and send it in integer, comma, a string, comma, an integer, then I know to use this method where we set the num tires to the local copy that just came in, num tires. So a common mistake is switching these 2. And if we were to accidentally switch these 2, you're setting a local variable to some value, right, num tires. And then at the end of this, that local variable disappears at the end of this method. So what you really did was nothing, right? You set a local variable and then the local variable disappeared. So you want to set the global variable's value. So you're updating the actual class variable's value. So we'll put the underscore on this side. Down here, we'll say we want to set the name. Whoa, just did that mistake. Okay, we want to set the actual global name to the local name. We want to set the year to underscore year. Now, a common way you'll see this in coding is they'll say this dot name equals, and you'll have a local copy of the variable with the exact same name. I personally don't like that. I know that's common practice. I like having some way to signify that this is a local copy and it's a different variable name. Okay, but it is really common to say this dot name equals name. All right, so that being said, now we've got a blank constructor that sets up a car to 4 tires, new car, year 2020, and then we've got a car that we can actually set up with our own, okay? So I'm gonna, and we need to print the year here too. So let's go to year. All right, so let's save that. We got 2 constructors setting up our 3 class variables. Let's go over here. Let's make a default car to new car, and then let's set car. I'm going to call it tripod. That's going to be a new car that has 3 wheels. It is called Super Tri-Mobile, and it is from the year 1982. It's a classic tripod car. You don't see many of those on the road anymore. Okay, so default car, let's print its values, and then let's go ahead and print the tripod car's values, and we'll see what comes out. So let's save the car runner. We've got the car here. I'm going to go back to my command prompt and I'm going to compile. I'm going to go back down here. And sure enough, the first one was the default values because I didn't set anything, right? I just said, make me a blank car. We luckily had set those values to something because we made the default constructor. And then the other constructor, we gave it starting values, which showed up right here. 3 tires, Super Trimobile 1982. Okay, so that's the whole idea of a constructor and how we would use it. Okay, now just going back to the slides, I want to go down to both the scope and then what overloading is. So again, as I mentioned, a really common mistake when people are first writing constructors is somehow they're either creating a local variable here. What you mean to do is update the global height, right? That the integer here is created in the class, so it's available inside everything in the class, inside every constructor and method to be updated. But here then, you create a new integer with the same name. And so this height only exists inside the constructor. And so when it reaches this bracket, that height disappears, and this one never got assigned. So it ends up being 0 at the end of the program because it started as 0 by default, right? The very first time any constructor is called, any unassigned variables are left at 0. You assigned a local variable value, which poof is gone. And so the height stayed 0. So here to fix that, you would just delete this. Again, another really common mistake is people saying, I'm going to set the WT, the local copy, equal to the global. Well, the global one's 0 by default. So here, not only are you not setting this one, you're actually even deleting the local copy. The local copy that they sent in, right? They sent in a value of 3. You immediately go, yeah, 3 equals 0, poof. Now the local copy 0 and the global copy 0. You hit the bracket, local copy disappears and you're left with 0. So again, just super common mistake to switch the sides or somehow mess up with the scope so that you don't actually update the values correctly. Okay. When you make a little UML diagram too, we always put the constructors first, and you know they're constructors because they have the same name as the class, and all the methods go below there. Okay, so overloading isn't just for constructors, right? You can have as many constructors as you want as long as they have different inputs. And just to go back there, they don't have to have a different number of inputs. I could even have a new car that just takes in an integer, and then right below it, I could have another constructor that just takes in a string name. And this can be really helpful for having like just being able to be more flexible in how you create objects. Like if I know these values versus if I know this. And there's no ambiguity in Java. It knows if you say in the runner car equals, like temp equals new car, and you send in a 5, it goes look for the constructor that has one integer input. Oh, it's right there. No ambiguity, right? Whereas if I sent in the quote 5 or a word like hello, it would go, oh, look for the constructor that has a single string as an input, and it would pick this one. So again, it's totally okay to have 3, 4, 5, as many constructors as you want. Okay, so I'm gonna get rid of that. So let's undo back. So I have a working program. There we go. But you can also overload methods. So here's overloaded constructors, but overloaded methods too. I could have the same thing, like 2 different reset functions, right? So it's the same function with the same name being defined twice. So again, like if you're a beginner coder, you're like, no, I can't create 2 integers with the same name, right? Integer A and then integer A, that would cause an error. But the difference is, because you have a list of inputs, you can do it with with functions, because there is no ambiguity between calling reset with no inputs and calling reset with a double as an input. Like those are 2 different things that Java can distinguish between. So here, there's 3 different resets. One that takes in nothing, one that takes in a single double, one that takes in an integer comma a double. And so sure enough, I've got 3 different resets that can easily be distinguished between. Woo! I hope that was helpful, you guys. All I'm going to do right now is just revisit the program from last week and kind of simplify it, clean it up a little bit. But that's it for new information. So I hope you enjoyed it. Okay, so I'm going to go back over here, and that was car and car runner. But the troll and troll runner from last week, I'm just going to open these up to split screen. I had originally made these blank trolls and then updated them after. So what I want to do now is just improve that so we don't have to update the values after. Instead of setting T1 and T2's name to rock and roll, I want to do that rock here and roll. Whoa, roly-poly. Okay, so boom. Now, I've made two trolls and they've already got their name. Now, I'll go make those constructors in a second, but I also want to set their starting health. Okay, so let's delete that. And here, let's say, set the first one to be 100 and this one to be 50. So that's the whole idea of a constructor. Is why later call on these functions to set the values. Here, I just want to go straight ahead and give them those starting values. So I'm going to go, whoops, I have troll open here. So, oh, I changed this a little bit. Why was troll class named chicken? I think I was making another video and just overriding this for some examples. Okay, so I want a public troll. So here's let's make this class public. Seeing here, public. Okay, now that we're there, I've got this name. I've also got a private int called health. The reason I'm making them private is that's just good programming practice with encapsulation. Again, I encourage you to Google it. We'll talk about what that means later on. Okay, so we've got our constructor. In order, we want the name and then we want the health. So we're going to take in a name, and then we've also got an int health in. And so right here, we set our name to name in, and we set our health to health in. Okay, so now we've got a constructor that sets it. So I don't need a method to set the name. I also don't need a method that sets the health, okay? I still want to be able to get or print the name, and I still want to be able to update the health, okay? So let's see if our program works now. We just made a slight modification to make our code a little more elegant. So I'm going to close this and open it in a different window. Java C star.java. Let's see, what did we do here? So let's go to the first one, private void print name. What is the error on troll.java with that? Oh, we had a bracket here that ended our class, and so it got to the next part and was like, what the heck's happening here? Let's save that. So often you just, when you run into an error, find the first one, and all the others were a cascade of stumbles and trips after that first error. So if you can just fix that first error, that usually solves the problem, or at least some of it. All right, so let's run troll runner. And sure enough, we've got rock and roll. Let's give the first one 99 damage out of 100, and the second one also 99 damage, and roll's dying again. That 50 starting health, not doing so well. And sure enough, then T1's health, which is rock, is left with 1, and the other one started at 50, so he's down to negative 49. All right, so I just want to show you how constructors work. I hope you enjoyed the video.